Today we're going to learn about solving equations with distribution. This is lesson 2.3. Our learning target today is to use mathematical properties to prove that two equations are equivalent or the same. We're going to do this by applying the distributive property while solving for the unknown value, the value that makes the equation a true statement of equality. Before we begin, let's just kind of talk about this idea of reverse PEMDAS or SADMEP. So normally when we have an expression that has only values, we are simplifying it down to a single value, right? And we are simplifying it in the order of operations, which we know as PEMDAS. When we are solving for an unknown, we have lots of numbers on the same side as the variable, the x. And we have to try to get the variable by itself, so we're trying to get rid of the numbers. So a lot of times we are confused as what number do we need to get rid of? Do we need to get rid of the -3, the 7, the 8, or the exponent? Which number do we get rid of first? So using PEMDAS backwards or using SADMEP is a strategy for figuring out which operation or number to eliminate first. So you always want to start with the easiest things to eliminate, which are things that are being subtracted or added. So if you look at the example here, we've got two things that are being added. We've got the 5 is being added and the 8 is being added. But because the 5 is in parentheses, this would not really count as addition or subtraction because it is inside the parentheses, and parentheses are saved for last. So the first thing that we would eliminate is the plus 8, the addition of 8. And then if we're using SADMEP, the next thing we're looking for is things that are being multiplied or divided. So we've got the -3 is being multiplied, but again, it is in parentheses. So our next step is to eliminate what is being divided on the outside. So we would eliminate the 7 that is being divided second. And then we would move on to exponents, which we know is this 2 right here. This would be the third thing that we eliminate. And now we are in the parentheses. And so we've got multiplication, we've got addition. And addition comes before multiplication. So we would eliminate the addition fourth. And then we would eliminate the multiplication fifth. So reverse PEMDAS is a way of figuring out which numbers to eliminate first, or what operations to undo first. So let's get into the first example. Here we have find the unknown value and use properties to justify the solution. So we've got steps over here, and our first step is to identify the variable expression. So we have the expression here, -177. This is not the variable expression because there's no variable in this expression. Then we have the expression -3 times 5x, there's our variable, minus 6, close parentheses. So our variable expression is the right side, so we're making this the variable side, and this is the number side. So we're trying to eliminate all of the numbers on the variable side. So our second step is to use SADMEP to identify what numbers or operations we need to undo first. And remember SADMEP, S-A-D-M-E-P. But I'm going to make an amendment to this step, number 2. If there's something to distribute, then you can distribute first. So here we are going to actually distribute first because there's an integer, this -3, that we can distribute into the parentheses. So that's what we're going to do for our first step. We're going to multiply this -3 through the parentheses. So our new equation will become -177. There's nothing to simplify here. Equals, now we have -3 times 5 is -15. Times x is -15x. And -3 times a -6 is a positive. And 3 times 6 is 18. So we have rewritten this equation after distributing. So how can we justify this new equation? We can justify it because we use the distributive property, dp. Now we're looking at the equation, and we've got two numbers. We've got -15 and we've got 18. So the -15 is being multiplied to the x, and the 18 is being added. So we're going to get rid of the addition first. So how do you get rid of addition? You use the inverse operation. And we know the inverse of addition is subtraction, and we want to subtract by the number we want to eliminate. So if we do it to one side, we must do it to the other side. So we have -177 minus 18. We're subtracting 18 from the left side. And we have -15x plus 18. And we're subtracting 18 to the right side. why can we subtract this number to both sides, or what allows us to rewrite the equation like this? The subtraction property of equality. We can subtract any number to both sides. So now, really a quick note is that when we write this in Schoology, it is important that we are placing the subtraction next to the number that we're going to simplify it with. So we're going to simplify it with this 18. So we were subtracting at the end of the expression. That's why we are also writing it at the end of this expression here. For example, if we wrote it at the beginning, our expression would look like negative 18 minus 177 equals negative 18 minus 15x plus 18. You can see here that the negative 18 or the minus 18 and the plus 18, we would have to commute using addition, the commutative property of addition, to get them right next to each other, and then we would have to simplify. So this is adding another step. We want to avoid that, so we're always going to subtract or add right next to the number that we want to eliminate. Now that we've subtracted both sides, we can go ahead and simplify. So we have negative 177 minus 18. I'm going to use a calculator, and I used it, so I know that this simplifies to negative 195. And then we have negative 15x, can't be simplified. We have 18 minus 18 is 0, and we always add 0. 0 is always added. Why can we write the equation like this? Because we can simplify things. This is not a property, but is a mathematical concept that you can always use. And now we know that anything plus 0 is itself, so we know that negative 15x plus 0 is just negative 15x. And we can bring down the negative 195. Why can we write the equation like this? Because the additive identity. Now that we are here, we need to eliminate the negative 15. So the negative 15 is being multiplied, and the inverse operation is division. So we're going to divide by the number we want to eliminate. So we're going to divide it to both sides. So we can rewrite the equation as negative 195 divided by negative 15 equals negative 15x divided by negative 15. It is the division property of equality that allows us to divide both sides by negative 15. Now we can go ahead and simplify. So we have negative divided by negative is a positive, and 195 divided by 15 is 13 equals negative 15 divided by negative 15 is 1 times x, and we simplify. And now we know that anything, or 1 times anything, leaves that value unchanged. So 13 equals 1x is the same thing as 13 equals x. Why? Because of the multiplicative or multiplicative identity. And this is our final answer. So we have just proved that this equation and this equation are equivalent, because each time we've rewritten the equation, we've given a justification using a mathematical property or identity. Let's move on to the second example. Okay, so here we are being asked to rewrite all of the equations using the justifications that are given to us. So the first thing that we're going to do is identify the variable side. The variable side in this example is the left side, and we've got the right side, which is the number side. Now we can go ahead and start by, and here it says DPE, which is division property of equality. So in the last example we distributed first, but this is telling us that we need to divide first. So if you think back to SADMEP, there's nothing that is being added or subtracted on the outside of the parentheses on the variable side, but there's something that is being multiplied. So we're right here. This negative 7 that we would normally distribute is being multiplied. So we can do the inverse operation to undo it. The inverse of multiplication is division, so we're going to divide both sides by negative 7. So we can put the left side in parentheses, just like this, and we can divide it by negative 7. And then we can do the same exact thing, which is divide the right side, which we don't have to put this in parentheses because there's only one thing. We can divide the right side by negative 7 as well. And now we can go ahead and simplify. So we know that 7 divided by negative 7 is 1. And we now have negative 2x plus 3 equals 119 divided by negative 7 is negative 17. And we know that 1 times the parentheses is just what's inside the parentheses. So we can drop the parentheses and say negative 2x plus 3 equals negative 17 because of the multiplicative identity. Now it is saying, okay, you are subtracting something to both sides. Well, we see that the number is being added. This 3 is being added. So we're going to subtract 3 to both sides, and we're going to write this at the end of the expressions. So we have negative 2x plus 3 minus 3. That way we don't have to commute them. Minus 17 minus 3. Now we can go ahead and simplify. We know that these simplify to 0. So we have negative 2x plus 0 equals negative 20. And the additive identity states that when you add 0, it leaves the value unchanged. So we just have negative 2x equals negative 20. Now it's saying you're dividing both sides. What are we dividing both sides by? The number that is being multiplied. So this negative 2 is being multiplied, so we're going to divide by negative 2. And we can simplify. Negative 2 divided by negative 2 is 1. Anything divided by itself is 1. And negative divided by negative is positive. 20 divided by 2 is 10. And now the last step, we know that using the multiplicative identity, 1x is the same thing as x equals 10. Example number 3. Okay, so now we have distributing a fraction. So you can see now what the number that's being distributed is a fraction. So instead of distribute a fraction and multiply fractions, it is best to turn the fraction into division. And we learned about how to turn a fraction into division. Distributing a fraction. So we can go ahead and identify that the variable is on the left side and that our number side is going to be the right side. Now we can distribute this negative 1/3 into the parentheses, but then we'll have to add and subtract fractions, which would be more difficult. So it's best to just try to eliminate what is being distributed like we did in the previous example. But now we have a fraction, not an integer. So remember, the inverse operation undoes something. And the inverse of a fraction is called the reciprocal. And what that means is if we want to eliminate the negative 1/3, then we need to multiply by negative 3 over 1. So we can write this in Schoology as negative 3 times, and we'll put the negative 1/3 in a set of parentheses, and we'll leave the negative in the numerator. So we're putting fractions in the parentheses, 2x plus 7, and we're multiplying the reciprocal on this side as well, so negative 3 times negative 27. Why can we multiply negative 3 to both sides? Because of the multiplication property of equality. Now we can go ahead and simplify. When we simplify, we know that reciprocals multiply to 1, and so we're left with 2x plus 7 equals negative 3 times negative 27 is a positive 81. And now we know that 1 times anything leaves that value unchanged, so we can go ahead and rewrite this as just 2x plus 7 without parentheses now that we don't have the 1 equals 81. This is the multiplicative or multiplicative identity. And now we can get rid of the 7 because it is being added, and we get rid of addition first. So we're going to subtract 7 to both sides since it's the inverse of addition. So we have 7, and we're going to write it behind because we want them to be right next to each other. This is subtraction property of equality, and we can go ahead and simplify. Now we have 2x plus 0 equals 74. And we know that this is the same thing as 2x equals 74 because of the additive identity. And then our last step is to eliminate the 2 that is being multiplied. So we're going to divide both sides by 2. And this is the division property of equality. And we know that this is 1x equals 37, which is simplify. And our final step is 1x is the same thing as just x equals 37 because of the multiplicative